So here we are in our wood shop. In addition to manufacturing handbells and our choir chime instruments on site, we have a fully functioning wood shop. As you can see here, these are 25-note choir chime cases that the hardware is being attached to. Here we go, entering into our cutting room. This is George and Louie. We do all of our cutting in this room. Here's where Bic and Dong actually are gluing the vinyl that goes on the outside of the cases to the cases. As I mentioned, we manufacture all of our cases here, including tables. We also do racks for our fifth, or lower fifth, or lower sixth, and lower seventh octave chimes. After these cases are vinyled, the hardware will then be attached, including corners, hinges, and the handle, and then the insert will be done. After the cases are done, they'll then be sent over to the respective departments, whether that be chimes or bells, where the bells and or chimes are put into the cases and out they go to the customer. This is our aluminum machine shop. We have this up here basically because the machines are pretty large and we didn't have any room down below in our other part of our factory. And also we don't really want to mix bronze and aluminum. The process is similar in that we turn the OD first and then we turn the ID. We make aluminum bells from G1 up to F sharp 3. And tuning a G1 from the outside diameter to the inside diameter could take about 1.5 to 2 days. After tuning, the tang's cut, they're sanded. We don't polish these as we do the bronze bells. We actually coat them with a finish, and we leave them matte, and then they are assembled in final assembly and sent out to the customer. Here are some of our aluminum bells just drying after being coated. This is Kung. He is demonstrating how we go about tuning a choir chime instrument. The tuning of a choir chime instrument depends on a lot of things, but generally speaking, it's the length of the slot depth. So what he's doing now is he's just elongating that slot. Similar to what we do with bells, he's essentially detuning the chime. It's a little bit higher than we need it to, so he just runs an end mill towards the end of the slot, making it several thousandths longer and dropping it into the range that we want the pitch. Here Mike is going to drill and tap a choir chime. Mike's with us for the summer, off on college break. So each one of our chimes, except for the lower 7th octave, will go through this process. First step is going to be drilling the holes in the appropriate area of the chime so that the clapper assembly is mounted where it needs to be, and therefore the clapper head strikes the chime at just the right spot to deliver optimal tonal quality. After drilling out the holes, now he's going to notate on the chime what note it actually is. He just does this with basically a punch. He'll mark whether the note and the number and hit it with a hammer. After drilling out the holes, put it in here to tap the holes so we can attach the clapper assembly. The clapper assembly is just attached to the chime with screws. After tapping, there'll be some of the material kind of left inside the chime. Mike here is just kind of cleaning that off. After drilling and tapping the chime, he'll take it over here and plug the chime. All of our chimes are plugged. The plugs are made out of rubber. Inserts a depth setter or depth gauge in there to make sure that the plug is set to the appropriate depth. The depth is determined by the note that you're trying to produce, and what it does is it creates increases the decibel level and the sustain of the chime. And there you go. This chime's ready for final assembly. As the chimes are completed in the machine shop, they're brought out to final assembly here. Each chime is stacked according to note, and when they're ready, they'll take the chimes and attach clapper assemblies to them, line them up here on the table, and voice them. Mary's getting set to put together a clapper assembly. So here she's putting on the bumper onto the shaft. After that, she'll attach the yoke to the shaft. The yoke is then drilled and pinned to add stability and support. Now Mary will put on the clapper head. Clapper head, as you can see, has a bunch of different settings, but unlike our bell, they're not adjustable. We set them here at the factory for best tonal response, and it's not advised that you change that. After attaching the clapper head, Mary will then attach 2 washers and the screw to hold the clapper on. After the clapper assembly is complete, it's attached to a thumb guard, 2 bearing screws similar to the clapper assembly of a bell. Main difference being the clapper assembly for a choir chime is on the outside, whereas for a bell it's on the inside. The bearing screws are adjusted to make sure that there is an even swing when it leaves the factory. There you go. Completed Malmark choir chime clapper assembly. After Mary completes the clapper assembly, it's then passed off to Chris. Chris will attach that completed clapper assembly to the chime with 2 screws. Check to make sure it's aligned properly. If not, he'll adjust. Make sure it's secure. Again, do some final adjustments on the bearing screws to make sure that the clapper assembly swings easily and freely. There you go. This is our shipping department. Bells will come out of final assembly and placed on the shelf. As orders are ready to go out, the shipping department will grab these bells, grab the required cases, pack the bells into the cases, and send them out. Here are some examples of our newest line. This is the Laura Bell line. It was created by the two owners of the company, Joanne Malta and Laura Moore. It is a way for Malmark to repurpose or reuse some of the bells that don't cut the mustard in for our musical line. This is meant to be high-end heirloom gift that you kind of pass down from generation to generation. We have wedding bells, Americana bells, anything you could possibly imagine.